Now that we have learned the 5 different ways to classify chemical reactions, we're going to talk specifically about reactions that occur in aqueous solutions. Double replacement reactions occur between substances in aqueous solutions in order to produce precipitates, water, or gases. Before we start talking about the details of reactions in aqueous solution, take a minute to define the 7 vocabulary terms that we will cover in this section. You can find the definitions in your textbook or online. These should be written on the note sheet that you are filling in as you watch the video. So what exactly is an aqueous solution? Well, if you can remember back to when we were distinguishing between elements, compounds, and mixtures, an aqueous solution is very simply an example of a homogeneous mixture that occurs when a substance, otherwise known as a solute, is dissolved in water, which we will call the solvent. Solvents are always the most plentiful substance in the solution, and as noted on the slide, homogeneous mixtures are those that you cannot see the difference between the solute and the solvent. As we begin to describe reactions that take place in aqueous solutions and write chemical equations for them, we need to remember to include an AQ in parentheses after the formula in order to identify the reactant or product that is dissolved in water. Remember that ionic substances will break down into their ions when dissolved in water. So instead of writing the formula together, we need to split it up into its positive and negative pieces. Once every product and reactant that is labeled as aqueous in the equation is split into its ions, we have what's called the complete ionic equation. Everything else in the equation will remain exactly the same. Solids are written as a complete formula as well as liquids and gases. An example of this can be seen using this equation. As you can see, NaCl and AgNO3, which are labeled as aqueous, have split apart, forming 4 different ions: Na+, Cl-, Ag+, and NO3-. As the reaction takes place, the ions begin to react, forming 2 new substances, AgCl and NaNO3. The AgCl, since it is marked as a solid, remains together, while the NaNO3, marked as aqueous, again splits apart into the ions Na+1 and NO3-1. As written below, you see the complete ionic equation with each reactant and product labeled as aqueous split apart into its ions. The process of writing complete ionic equations can be tedious, as there are often 2 or 3 substances labeled as aqueous that need to be split into their ions. However, after the complete ionic equation is written, the net ionic equation can be determined by crossing out the spectator ions. These are the ions that appear exactly the same on both sides of the equation. Using the same equation as on the last slide, you will notice Na+1 and NO3-1 each appear on either side of the arrow. This means that those 2 ions are spectator ions and can be crossed off in writing the net ionic equation. The result is a much simpler equation that only involves the ions in the reaction that are used to create, in this case, the solid, liquid, or gas. There are three types of reactions that occur in aqueous solutions. Those which react to form precipitates or solids, those that react to form water, which you know is H2O, and lastly, reactions that form gases. Take a minute to look at one example of each of the three types of aqueous solutions. Keep in mind, none of these equations are balanced, and everything labeled as aqueous has not yet been split into its ions. Writing complete and net ionic equations can be tricky at first, but with a few examples and some practice, you will get the hang of it in no time. Check out these 3 keys to success as you begin to write your very own complete and net ionic equations. Don't forget to always start with the balanced chemical equations. Remember that coefficients apply to everything in a formula, so they will be added to each ion written, and spectator ions need to be exactly the same on both sides of the equation to cancel each other out. If we take a look at this example, the first thing that needs to be done is to balance the equation. This can be achieved by adding a 2 in front of the KCl on the product side. Now, there are an equal amount of atoms of each element on either side of the equation. The next step is to write the complete ionic equation by taking the 3 substances with an AQ after them and splitting them up into their ions like this. A few things to point out about the complete net ionic equation is that only substances that are labeled as aqueous are split apart. Anything labeled as solid in this case, which is the COS, stays together. The other piece of information you should remember is that the number of ions matters. So the coefficient of 2 we put in front of the KCl gets added to both the K and Cl ions. The next and final step is to determine the spectator ions so that they can be crossed off and the net ionic equation can be written. If we look at this reaction, there are 2 positive K ions on either side and 2 negative Cl ions on either side. These can be crossed off because they are exactly the same. We'll call them the spectator ions, and the remaining pieces, S negative 2, CO plus 2, can be rewritten in the net ionic equation in order to form your COS, which is in the solid state and therefore stays together. And that's it. One example on how to write a complete and net ionic equation. You will be practicing 5 of these on your own.